Okay, this is the last part of chapter 3, section 2, and it's just one little bitty section. It's not going to take too long. It's a very good thing you decided to watch this video, though, because there's a typo on the sheet. You have in the sheet here, it says 1/2 pi r squared, and that pi is a typo. It's not the number pi. That should be the angle theta in here. So the formula should read area of a sector is 1/2, excuse me, switch the order, 1/2 r squared, and theta should be the formula on there. So if you want to change that in your sheet, that would be outstanding. And when you walk in with the corrected version on Wednesday, I'm going to be very impressed. Like, oh, that kid watched the video. And make sure you don't tell the other students. We'll kind of make fun of them when they come in and have the wrong formula. No, we won't really do that. But anyway, the area is 1/2 r squared theta. And maybe one question you're asking is, wait a minute, a sector area, what is a sector? And a sector, first think about just a circle. And a sector is just if you take a slice of that circle. So I go here and I measure out some kind of an angle theta. Oops, that's a theta right there. And then the sector area is the area of that one little slice right there, that one little slice of pi. That's a sector. So it's just a slice of pi, a slice of the circle, but we want to find the area of that sector. We've got our formula right here, and this formula works every single time for sector area, 1/2 r squared theta. I want to take just 1 minute, though, and explain where the formula came from. Then we'll use the formula, and the use will be very straightforward. Okay, to explain where it came from, the area of a circle, you should know, is pi r squared. And now, one thing, hopefully that's occurring in chapter 3, is every time you see now a pi, you used to think of the number 3.14, now when you see pi, you're thinking, wait, that reminds me of an angle. Because we have radian measure now, and we measure radian angles with pi's and pi 4s and pi 6. If you think about a circle, when we rotated in a circle, our rotation was 2 pi. And our formula doesn't really have a 2 pi in there, but if we took this formula area and multiplied the top times 2 and divided by 2, it's really the same formula. And now when you look at that 2 pi, you're thinking, wait a minute, that's my angle, 2 pi, and I can adapt that formula for any angle. So my area is my angle times r squared over 2. And if you look up above, at least look up above the corrected version, that's what we have for our sector area. It's 1/2 r squared times theta. So that's a times in there. Where does it come from? It basically came from the formula for the area of a circle, pi r squared. And considering the fact that we didn't have a full 2 pi revolution, we had whatever our angle theta was. Okay, the use of the formula is going to be very, very straightforward. So here I've got a problem that gives me the radius is 59.8. So there's some units on that. Let's call that centimeters. And the angle theta is 2 pi thirds. I would like to know the area. So the area is going to be 1/2. The radius is 59.8. We'll square that. And the angle theta is 2 pi thirds. And just like our previous formula, it will work when we're measuring in radians. If you're measuring in degrees or trying to fool you, switch that degree measure to...
Garrett Dawkins, please call extension 6209. Garrett Dawkins, please call extension 6209.
I am after school, and sorry about that interruption. Anyway, we've got 1/2, we've got our r squared, and now we've got our angle, and our angle is measured in radians. And if they ever try to fool you and give you an angle in degrees, you will immediately switch that degree measure to radians. At this point, we are nearly done. Pull out your calculator, and let's get the area of this sector. And so I've got a 1/2. I'll take it times 59.8. I'll square that, and my calculator knows the order of operations, so it will square that first. Then I'll take it times 2 pi divided by 3. And this will give me my area. Since my radius was in centimeters, my area will be in square centimeters. So I get this for my answer, 3,744, make that a little bigger, 3,744, and that would be centimeters squared. So 3744 centimeters squared. And that's the area of the sector when I cut out that portion of the circle. And that completes this part.